Welcome, students. I welcome you to one more video lecture. It is this time I want to give you in this video the single method for solving the multiple integrals. Uh, Actually, when you come across the integrals like this, uh, a cos theta plus b sine theta upon c cos theta plus e sine theta, where a, b, c can be real numbers, or this form cos theta by this, or this form, it is just like that, a sine theta b cos theta, or this integral, when we convert this integral sine by cos, it will be numerator cos theta upon sine theta plus cos theta, or this form. For all such integrals, we have a single method we follow. Some of you are trying it for converting sine and cos in tan. If you convert this sine and cos in tan, like cos x, you write 1 minus tan square x by 2 upon 1 plus tan square x by 2. Then this sine x in terms of tan, you write 2 tan x by 2 upon 1 plus tan square x by 2. Then you put tan x by 2 is equal to some variable, say z or theta, x. Then you go in that way also. But that is for such integrals, that method is a bit, or sometimes it becomes too lengthy. You have, for such type of integrals, excluding this one, not this one. I have mentioned here, it is not applicable to integrals like this, where you have two. In numerator, you don't have sine, you don't have cos, okay? You have some constant by 4 sine x minus 3 cos x plus 5 dx. Such integrals we do by the method of Weierstrass substitution. That is known as Weierstrass substitution. Weierstrass substitution. It is, you put, say, z is equal to tan of x by 2, or t is equal to tan of x by 2. Here also you cannot apply the method that I am giving for such integrals. Of course, you can do these questions also by Weierstrass substitution, like tan of x by 2 is equal to t or z, then you go ahead. But that will be a bit a lengthy one. You remember, you just look these integrals. When and how can we come to know that we have to apply that method which I am just discussing with you? Very simple method. You will see when you come across in numerator involves sine x or cos x or both, but not in multiply. It should not be like this sine x cos x. Okay, it should not be involved in numerator as constant. Denominator should involve the sine and cos like this, sine and cos like this, which is actually it is actually a cos x, b sine x. In the numerator I have sine x. Okay, in such cases, remember, you have a method that follows. You can solve such all these integrals within no time without converting these. Sometimes you have cos x dx by sine x plus cos x, or sine x by this. If you don't have cos here, you have sine x plus cos x, don't apply that method which I am just discussing with you. Remember this, that numerator and denominator must involve sine, cos, but sine cos should not be in the product. Numerator should not involve only constant like this. In that case, you should not apply. You will use the Weierstrass substitution, z is equal to tan x by 2, or you can go by some other method also. But this is, no doubt you have, for solving such integrals, you have different methods. But we discuss with you the one method which is very simple, and you can solve these integrals very, very short, in a short period, this space of time. So that is why I have given him the name single method for solving many integrals of types these. And remember, not for this, not for this. How we proceed? This is the method. This method I want to discuss with you. This is method when you come across integral like this. You write numerator you express it. Numerator is equal to some constant, say lambda times denominator, then some other constant, say mu times differential coefficient of denominator. Very simple to remember. When you come across all such integrals, how you proceed? Express numerator lambda times denominator plus mu times differential coefficient of denominator, where you find lambda and mu are to be found out in a proper way by comparing the coefficients, because we want to have lambda and mu in such a way that this numerator, when we substitute the corresponding value for lambda and mu, numerator should be equal to this. This is a very simple and short method. I will discuss some questions from this out of these 6 or 7 questions. Let me discuss, and I will later on deal with this question. It is a bit lengthy, but if we cannot solve it by this method, it will be difficult by this method. We will use here in such cases Weierstrass method. We remain with me. Let us have some questions with solution. Yes, welcome. I have taken this question. I want to discuss the solution with you. This is I equal to 7 cos x plus 3 sin x upon 3 cos x plus 2 sin x dx. I have already told you you have such type of questions where you use the method which I have discussed with you. So in this case, one method is you may convert this sin cos both in tan, then use the Weierstrass substitution. But in this case, you can avoid that because both numerator and denominator involve sin and cos, and some constants, multiple constants. So we write here, let us express numerator is equal to lambda times denominator plus mu times differential coefficient of denominator. So you find out then lambda and mu in such a way that left side becomes right side. You are assuming it. Be cautious. We are assuming let our numerator be equal to this. So what is the value of lambda and mu when we write in this way? Numerator is your 7 cos x plus 3 sin x is equal to 7 cos x plus 3 sin x. It is lambda times, what is your denominator? Denominator is 3 cos x plus 2 sin x plus mu times differential coefficient of what? Denominator. Differentiate that. Derivative of this cos, you know, it is minus sign. So it is minus 3 sin x. Derivative of sine, it is cos, plus 2 cos x. Let us name this first. Now we have to find out lambda and mu. How we proceed to find out lambda and mu? Just see. We compare both sides. Compare coefficient of sin x here. Here I will compare coefficient of cos x. Compare the coefficient of sin x and coefficient of cos x. Look here. Coefficient of sin x. You have here sin x, left side. Sin x, its coefficient is 3, is equal to. Come to right side. We are comparing coefficient of sine. This is sin x. Its coefficient is 2, but when this lambda goes inside, when you distribute this lambda, it is right side 2 lambda. Plus here, sine, coefficient of sine is minus 3, but lambda is out. So it is minus 3 mu. Mu is outside, minus 3 mu. So I will again tell you, coefficient of sin x is here, 3. Here it is 2 lambda, and it is minus 3 mu. Now we come to coefficient of cos. Here you have cos, right, left side, it is 7. Coefficient of cos x is 7. Then come to the right side, coefficient of cos x is 3. This will be 3 lambda. 3 lambda, and here it is cos 2, it is plus 2 mu. Okay, you have to solve this equation. This is your second, and this is now third. You have to solve second and third for lambda and mu. You solve them for lambda and mu. Now this is your 2 lambda second minus 3 mu is equal to 3. That is 3 lambda plus 2 mu plus 2 mu is equal to 7. We have to solve this. How you solve? You can go by elimination method. For that, if you want to have the coefficient of lambda same here, I will multiply this equation by this 3 and multiply this equation by 2. You know that because I want to have the coefficient of lambda here same. When I multiply this by 3, it is 3 2s are 6 lambda minus 9 mu is equal to 9. I am multiplying second equation by 2. It is 6 lambda plus 4 mu is equal to 2, 7 is 14. Now you subtract them. Subtract. When you subtract these, first you make the coefficient same by multiplying the first equation, that is second equation, by 3, and this equation by 2 to have the coefficient of lambda same. You see where we have reached now. You just look. When we subtract it, lambda goes, and this is 9 mu and minus 4 mu. What is this now? 9 mu minus 4 mu. It is minus 13 mu. And left side this is positive and this is minus 14, and minus 14 plus 9. What is this? Is it equal to minus 5? Yes, it is minus 5. Minus 14 and plus 9, it is minus 5. Okay, and this gives you your mu is 5 upon 13. You have found out mu 5 upon 13. You can use it any one of the two equations using this mu. Let us use using value of mu in, say, second. You may use, what is that? It is 3 is equal to 2 lambda, okay, minus 3. The value of mu is 5 by 13. Just to simplify this, this will be 3 plus 15 by 13 is equal to 2 lambda, which implies that 39 plus 15 by 13 is equal to 2 lambda. Is it okay? Yes. It is. Add this. 9 plus 5 is 14, 1 carries. 54 by 13 is equal to 2 lambda. You can take the cancellation here. 2 2s are 4, 2 7s are 14. So your lambda is 27 by 13. So you have got lambda 27 by 13. Okay, you have got mu 5 by 13. Use lambda and mu in first. Use lambda and mu in first equation. You have found out lambda and mu. You see how we compare the coefficients, coefficient of sine and cos. Then we use it lambda and mu here in this equation number. This is what is called equation number first. Just look at it. Well, I have used the value of lambda and mu in equation number first. Now, very important stuff, how we go now. You have this numerator, that is 7 cos x plus 3 sin x, and this is the derivative of this is the denominator, and this is the derivative of denominator. We divide both sides by this. After this setup, we dividing both sides by denominator of the integral. denominator of integral. What is that? Divide both sides by denominator of integral. It is integrand. In fact, it is integrand, denominator of integrand. It is 3 cos x plus 2 sin x. We divide both sides by this. What do you get? This is 7 cos x plus 3 sin x by 3 cos x plus 2 sin x. It is 27 by 13. Then this is 3 cos x plus 2 sin x upon 3 cos x plus 2 sin x, and this is plus 5 by 13 minus 3 sin x plus 2 cos x by 3 cos x plus 2 sin x. This goes, this is same thing. Now integrate both sides. Integrate with respect to x. This is your given integral. When you integrate this, this is I. This turns out to be your I. This is 27 by 13 integral of 1 dx, because this is now 1. Then plus 5 by 13 integral of minus 3 sin x plus 2 cos x upon 3 cos x plus 2 sin x dx. This implies what? Yes, this implies your integral I is now equal to, this is the I is 27 by 13x, integral of 1 with respect to x, 13x, then plus 5 by 13. And what is this? This is f dash x by fx. Now this comes, numerator is a derivative of denominator. When you differentiate this 3 cos x plus 2 sin x, it is minus 3 sin x plus 2 cos x. This is f dash, this is fx. When you have the integral like this is log of the denominator. So it is plus 5 by 3 log of denominator, log of 3 cos x plus 2 sin x. Plus c you can write because it is indefinite integral. So this is how we integrate such type of question. Shortcut. It is a shortcut. You can do it within minutes without using that what is called this Weierstrass substitution. Otherwise, you can also go by Weierstrass substitution, but it will take you time to reach at this step. And you have seen how we reach at this step very easily and very quickly. So it is f dash by fx. So this is actually utility, the beauty of this, that we get this as f dash by fx. Okay, when we find lambda mu in such a way, then this is f dash by fx, this is log of the denominator. This is how we do it. Let me have one more question with you. Yes, welcome. Let us have the solution of this integral. It is same, but we have to just transform this numerator involving this sine or cos, and denominator also. How you proceed? You write this integral. I is integral of, this is cos theta by sine theta upon b plus a cos theta by sine theta d theta. Because it is cot, you write it cos by sine. If it was tan, then you have sine by cos. Okay. Well, this is I equal to integral of, this is cos theta d theta by b sine theta plus a cos theta. This is now your integral. By taking sine theta LCM from numerator and denominator, then you cancel it. You get it cos theta d theta by b sin theta plus a cos theta. In this case also you write, we express numerator is equal to lambda times denominator plus mu times differential coefficient of denominator. We go like this. Okay. Now what is your numerator? It is cos theta is equal to lambda times, what is denominator? It is this b sin theta plus a cos theta plus mu times, what is differential coefficient of denominator, derivative of this? It is b cos theta minus a sin theta. We differentiate this sin with respect to theta, cos, it is cos minus sin, it is minus a sin theta. Now compare coefficients, name this second. Compare coefficient. You have coefficient of cos theta here, then you compare coefficient of sin theta. What is coefficient of cos theta here? Left side you have 1. Here cos theta is here a lambda. Cos theta is here plus b mu. Then sin theta, compare. You don't have sin from left, so right, it is coefficient 0. You don't have sin from left, it is 0. You have sin here, it is b lambda. Okay, it is b lambda. You have sin here, it is minus a mu. Okay, so from this you get a mu is equal to b lambda, or you can use mu is b by a lambda. Your mu is in terms of lambda, b by a lambda. Now use value of mu here. In this case you will use value of mu. What do you get? Let's look. It is 1 is equal to a lambda plus value of, it is b times value of mu is b by a lambda. It is 1 is equal to a plus b square by a. Just look, b is b square by a, lambda is out. It is 1 is equal to a square plus b square by a lambda. That gives lambda is equal to a upon a square plus b square. This a goes here. So your lambda is a upon a square plus b square. So your mu is, what is your mu already found? It is b by a, the value of lambda, a by a square plus b square. This goes, so you have found mu also, b by a square plus b square. So lambda is found, mu is found. Use now this lambda and mu in this equation second. In this equation we will use it here in this equation number second. Okay, using these values in second, use lambda and mu in equation number second. You get cos theta is equal to lambda. What is lambda? Your lambda is there. It is a by a square plus b square into b sin theta plus a cos theta. Then plus mu is plus b by a square plus b square. What is your this? It is b cos theta minus a sin theta. Okay, divide both sides. Divide both sides by what? B sin theta plus a cos theta. What is it? It is the denominator of this integrand, b sin theta plus a cos theta. When you divide both sides, it is cos theta by b sin theta plus a cos theta. And when you divide here a by a square plus b square, you divide by this b cos theta plus a sin theta. b sine theta plus a cos theta, it will be 1, and here plus b by a square plus b square, it is b cos theta minus a sine theta by b sine theta plus a cos theta. Then you integrate with respect to theta on both sides. This is your given integral. You get I is equal to, this is a upon a square plus b square integral of 1 with respect to theta, then plus b upon a square plus b square integral of what? It is b cos theta minus a sine theta by b sine theta plus a cos theta d theta. Okay, this is your I is equal to a by a square plus b square. This is your theta. This is your theta because integral of 1 with respect to theta is theta. This is plus b upon a square plus b square. This is f dash by fx. This is log of the denominator, log of the sine theta plus a cos theta. And it is in fact indefinite. You can add c constant of integration. You see, you can solve this multiple integrals when you come across numerator and denominator involving sine and cos and some constants with multiple constants. You can use this method. This is known as method of adjustment. This is called method of adjustment. This method we use by express this and this. This is called method of adjustment. Remember this, method of adjustment. We adjust numerator as lambda times denominator plus mu times differential coefficient of denominator. This is a method of adjustment for such questions. So you can solve these with these, and we will be meeting in next lecture. I hope you can do some questions. And remember that it is only mathematics that develops or activates your rational brain. Love mathematics. Thank you very much.